Welcome back to Command Line TV. This is episode 9. Today we're going to talk about redirection and command substitution. Do you have any follow-up from last time?
Last time we did installing programs and package management. My one question is we used apt upgrade and apt update. Can we run apt upgrade without running apt update, or will that cause any conflicting issues?
You can run upgrade by itself. Normally you would run update and then upgrade together. It's fine to run upgrade by itself, but what it will do is only upgrade packages that it already knows about. So what's happening is the apt subsystem keeps like a package cache, and so it knows the last time it did an update what were the versions of all the packages that were available. And upgrade will look at that package cache and upgrade anything that can be upgraded. But unless you do update, you're not getting the freshest stuff. You're just getting the stuff from the previous update. So it's fine to do that. It doesn't hurt anything, but you just might not be getting the very latest.
I guess the last question we have would be in terms of uninstalling a package. What's the proper way of doing that so there's no conflicts?
So when you want to uninstall something, there are a couple of options. The simplest is if you do apt-get and then the command remove, and then you put the name of a package or multiple packages. So maybe we want to remove ImageMagick. This will remove that package and delete the files from the system. However, it does leave behind the configuration files for ImageMagick. So the thinking is that if you install it, and maybe you customized the installation of this package in some way by editing some of the configuration files, it doesn't want to remove your customizations, because if you install it again later, then maybe you want to keep the way it was customized. So remove removes most of the stuff, but it leaves behind a little bit. An alternative to that is purge. Purge will remove the package as well as all the configuration files, even if you made changes to them. So if you really want to be sure that everything is gone, then purge works fine. And then we saw there are cases of dependencies, right? So sometimes when you install a package, it brings along some other packages that one needs as dependencies. So just uninstalling ImageMagick doesn't necessarily remove all those dependencies. And there's another command you can run called auto remove. You don't need to put a package name here. It's just that whenever you run auto remove, it'll look for any packages that are no longer required by other packages that you've installed. So if ImageMagick needed some library that nobody else needs, it can remove that. If some other package does still need that library, then it will keep it. So it's very smart about managing these kinds of shared dependencies and conflicts and so on. One thing to be careful of, since you mentioned conflicts, is the upgrade and install commands support an option called -F or force. And this is usually a bad idea. What it means is that if it can help in a couple of ways, but it can also be harmful. If the package requires dependencies that are not installed properly, you can use force to try and install it anyway, and maybe it'll work or maybe it'll be terrible. If a package is going to overwrite files that another package has already installed, that's a bad thing that normally apt will try to prevent, but force will allow that to happen. So once in a while, force might be the thing you need to solve some problem, but usually it's just going to cause problems, so try to avoid it if possible.
So today we're going to learn about redirection, which utilizes the greater than, the less than, and the double greater than symbols. What are the purposes of these?
So redirection is about controlling where the input and output of different commands come from. So every command that you run has basically 3 streams that are associated with it. 3 streams of data. They are standard input, the standard output, and the standard error. And so error is also an output stream, but it's meant to be used for things that are not part of the normal output, but things that are error messages or warnings or stuff like that. So the way it works is that when you put together a pipeline, so if I do like ls help, whoops, can't have a space there, and then pipe that into less, what I'm doing with this pipe is connecting the output of one command to the input of another command. And then where standard error comes into play is if this ls command has some warnings or error messages it wants to put out, they do not get piped into less or into whatever the rest of that pipeline is. So we could try out some examples of that. One command that generates like both standard output and standard error very easily is grep. So we did grep to search through files before, and I'm going to search for copyright in all the files in the current directory. And we saw this before, that it will generate some lines where this is the file name and then the content of that file name, which contains our keyword out here. But it also has these error messages that come from grep. So whenever it hits a directory, I didn't tell it to go into that directory or ignore directories, so it's giving me a little error message there. So that's the standard error that we're seeing. And so normally when you run grep, the standard output and the standard error are both just dumping content onto my terminal. But I can redirect that in different ways. So let's try redirect to a file. I'm going to put a greater than and then a file name. So let's call this like copy matches dot text. So what this will do is run that command, but the standard output, instead of being attached to another command like less, it will take that standard output and write it to this file name that I've given here after the greater than. And you can have a space here or not. That doesn't matter. So if I do that, what happens is all of the legitimate output of that grep got directed to that file, so I don't see it, but I still see all of the error messages because the error messages were going out on a separate output stream called standard error. And then if I want to redirect both output and error to the same place, there's a way to do that. It is using the ampersand. The ampersand, there's one way to do it with this, but I think it's a little more complicated. If you put the ampersand after the greater than, and in that case you do need a space, I believe. Or no, you do not need a space there. You don't want a space there. This will write both of those. Let's say both.txt for that file name. So now I don't see any output from that command because both the standard output and standard error went to the same file. So let's take a look at those files. Copy matches.txt contains just the matches that we saw and no error messages. And then copy both.txt contains the matches and also, I think I saw one up here, the error messages when I have directories. So that's redirecting the output.
So besides the grep command, can redirection be used with things such as cat?
Yeah, cat is often used to just directly put some data into a file. You can use a text editor for that, but this is a really simple thing, and we can use it to illustrate some of the other output redirection operators. So if I run cat all by itself, all it does is it copies its standard input to its standard output. So if I type hello, it says hello back, and so forth. And then when I'm done, whenever you've got a command that's waiting for you to type something for its standard input, when you're all done, you can type Control D to say that that's the end of the input. So I'm going to hit Control D, and it takes me back, and I'm done running cat. So what if I did cat, but I redirect the output somewhere? So we could call it output1.txt. And this time I'll type line 1 test. This is line 2, Control D. And now we didn't see it echo those lines back to me because instead it echoed them to the file that I specified. And then if I look at the contents of that file also with cat, then it shows me those lines that got saved there. And then I could open that with a text editor or something like that and edit it further if it needs it. So let's try that again. If I cat to the same output file, and we'll do line 3, hello, testing, line 4, Control D to stop. And now my output file just contains the latest stuff. It actually overwrote the previous content. So you got to be really careful with this redirection operator. It will, if that file already exists, it will overwrite what's there, and so what's there gets lost. An alternative to that is if I use the double greater than. This means to take the existing content of that file and append to it, add to the end. So I was up to line 4, I think, or did I do 5?
Yep, line 4.
Line 4, all right. So this is line 5, and now line 6, and Control D. And when I output the file now, it has 3 and 4 from the previous run, but I appended 5 and 6 to the end. So that's one way that we can distinguish between the single greater than to possibly overwrite a file and start from the beginning, or the double greater than, which appends onto the end of the file.
So the double greater than and the single greater than can both create new files if they don't exist. What if you just want to add a no clobber option to it?
Yeah, so if you want to make sure that it doesn't overwrite some file that already exists, we can set an option in the shell to make it a little safer, just like we made those aliases for MV and CP and so on, to make sure that they don't overwrite files. And the way to do that is a shell option which you set with set-o, and the name of that option is no clobber. And so normally I would want to do that in my bash RC or somewhere like that so that it can be saved, and every time I start a new shell I'll have that option set. The way I did it right now, it'll only take effect for this particular session. But now if I do cat into my output1.txt, it will actually prevent me from overwriting a file that already exists. So that's kind of nice. But if I do double greater than, that would not overwrite a file because that's going to append, and that's okay. So the no clobber doesn't prevent that. So that's a simple option you might want to put in your bash RC to make sure that this overwrite doesn't happen. All right, so the final type of redirection you might want to do is directing standard input from a file. So you've got a file and you want it to become the input of another command. So for example, I just created this output1.txt, and if I want that to become the input of, like, let's say grep. So if I grep for line, okay, that's the keyword I'm grepping for. Now grep and a lot of commands that can work in multiple ways. So I can just put the file name on my grep command line and it will do that grep. Okay, so it matched 4 of those lines, but not the last line, so that one got omitted. But I can also specify it using a less than operator, which is redirecting from that file, and it does the same thing. So I can think of doing that with grep or head. Let's say I want to see only the first 2 lines of this file. And in both of these cases, I can either use the redirection operator or not. It doesn't really make a big difference. But there are some commands where you would have to specify it as a redirection instead of, because it just doesn't support reading its commands from the, or its files from the command line. Now I can mix input and output redirection on the same command line as well. So if I've got a file output1.txt and I wanted, like, let's say grep for append, which I know matches one of those lines, and then I can also output the result of that into output2.txt. So no output appears on the terminal, but my grep ran, it took its input from this file and it dumped its output to that file. So the output only contains that one line that matched the keyword that I searched for.
So in one of our previous episodes, we ran cat and then piped it into less. A few commands ago now, though, you just ran less and then the text file. What's the difference between those two?
Yeah, so we normally were using less, like I did double-help pipe less or something like that. And so what less is doing is giving me a page at a time, but it's getting its content from the pipe. So it's taking its standard input and showing it to me a page at a time. But just like I did up here with head, head can take its standard input from a redirection, or it can use a file. So I can do the same with less. If I want to, there must be a README here, yeah. So if I want to see the contents of this a page at a time, I can specify it as a file like that, less README, and it shows me a page at a time. Or I can run less and redirect the contents of README into it, same thing. Or, this gets even crazier, you can run cat. Cat, of course, will just dump out the content, but then you can pipe it into less. Same thing. Or you can redirect from the README file into cat and then pipe it into less. And these become like, useless at some point. Like you're just adding some small layers of complexity to it when really all you want to do is less README. But it just gives you a sense of the flexibility. Sometimes these, the way that these commands works, they do come in handy when you're building long pipelines. And we've seen cases of doing like grep and cut and sort and grep and stuff like that. And the very nature of these commands that allows them to be plugged together to build those big useful pipelines also allows them to be plugged together in fairly useless ways.
So now we'll be moving on to command substitution. The two main symbols that it uses are the backtick and the $parentheses symbol. But first, what would command substitution be used for?
So it's a way of combining two different commands. And we've seen how to combine two commands using a pipe. So when you do like ls pipe head or something, you're taking the output of one command and making it the input of another command. What the back quotes do, or command substitution, is, let's say I do ls, this doesn't make any sense, but let's say I do that. So I put one command in back quotes, and this is the, it's not the normal apostrophe character, it's the back quote that appears usually underneath the tilde. So tilde is the shifted one, and without shift it's usually that. So this takes the command in back quotes and executes it. It has some output. And then it takes that output and it pastes it in that position on the command line. So it will then run ls, where what appears out here is the output of the previous command. Okay, so let's try to come up with a better example of that. I'll start with a grep command. So when I do something like grep copyright star, we know what that does. It just finds matching lines. But there's an option to grep -l, which means only show the file names that match. So if I do grep -l copyright, I still get these error messages about directories. But other than that, it's just showing me file names. It doesn't show the text of that file where it matched, but just the file name itself. So then what I might want to do is take those file names and pass them to another command to do something different with them. For example, I might want to delete them or move them all to a different folder or something like that. So let's make a new folder, call it stuff. And what I want to do is move. What are the files you want to move? Well, I want to move all the files that match copyright out of star, which is all the files in the current directory. And then where do you want to move them to? The new directory I created called stuff. So there are two commands here, move and grep. The grep will run first, and the output of grep, the standard output of grep, is then pasted into the command line at this point where the quotes are now. So that will get replaced by the output of grep, and then I can move all those files into stuff. And so what I'm seeing here is just the standard error of the grep, right? So it's only the standard output that gets pasted in, and then the standard error still comes out on the terminal. But what it did do is it moved all of those files into stuff. So if I look in that stuff directory, I've got a bunch of files in there. Every single one of those files is one that had copyright appear within it. And now the files that remain in the current directory do not have copyright in them. So if I do grep copyright in the current directory, I only get the error messages. All the files that matched have been moved aside. So that's a pretty good example of a command. Whenever you've got a command that might return a list of files, then you can use that as, with the back quotes, with the command substitution, as parameters for things like move and remove and copy and other commands that expect file names on their command line.
Now, does command substitution only work on text files, or can we use it for images as well?
Oh, we can use it for lots of things. So a pretty neat way that we could use it for images is like to select some image files according to some criteria, and then apply maybe a mogrify to crop or shrink those images or something like that. So let's go look at the, I think that was in downloads, pics. These are the images I was working with in our episode on image magic. And so if I do identify on all of these images, I get a line for each image that tells me the resolution and so forth. And to keep this relatively simple, let's just say that I grep, and I'm going to look for images that have a width of 3264. So it'll have like the 3264 and then an X. And so that's a subset of the images, right? Most of them are by 1952, but this one's actually a little bit different. But now I've been able to use identify and grep to select a particular set of image files. And then I want to strip this down so that it's just the file name that I'm seeing, not the rest of this information. So I'm going to use cut. And what I'm going to pretend is a delimiter here is this left bracket symbol, right? So if that's a delimiter, then the first field would be the file name, and the second field would be all the rest of this. So I can say the delimiter is left bracket, and I want field 1, and now I just have a list of file names. So that's a perfect type of command that I could put in my substitution. And when commands get a little more complex like this, and especially when you use nested substitution, these back quotes don't always behave very well. They can't be nested within each other the way parentheses can. So what I'm going to do is use this alternative syntax for command substitution, which is dollar and then parentheses around the part that gets substituted. So reminder that this outputs a list of file names. So if I put it in back quotes, it's going to expand to that list of file names, and then I can use that within another command like mogrify. And let's say I want to shrink these by, I don't know, 10% or something like that. So first we're going to use this pipeline to select the files, and then we're going to apply mogrify to all of them. That can take a moment because I'm shrinking a bunch of files, but it came out pretty fast. If I list these files in reverse order by modification time, then I see that all of the ones that appeared in this list are at the end. So starting with 201, 202, 207, these files were the most recently modified. And if I look at some of them, let's just take 2012 and 7. .jpg. Do you remember this bracket wildcard? So this will substitute, another way to do this is a question mark. Question mark just substitutes a single character, so that's going to match all the images that have 020 something. But I want to only select ones that end with 1279. because they were in my initial list. So I'm going to look at those files that I just shrunk, at least the first 4 of them, and you can see that they're very tiny images now, only 10% of what they were, and the way I selected those was using the dollar parentheses and this subcommand.
Well, today we covered the basics on redirection using the greater than, less than, and the double greater than symbols. We also touched base on command substitution using the the backtick, as well as the dollar parentheses sign.
So thanks for joining us today, and we'll see you next time.